Today is December 18th, 2025. We are not just approaching the event, we are enveloped in it. With less than 24 hours remaining until the interstellar object known as 3 Atlas reaches its closest point to Earth, we find ourselves at the final compression of the timeline. This is the moment when months of observation condense into hours, and those hours compress into minutes. There's a distinct feel about this last day. It's not louder or more dramatic, but rather quieter and more intentional. Throughout much of this year, the prevailing assumption regarding 3 Atlas had been one of stability. It was positioned as a rare yet ultimately familiar event, an interstellar comet, a fragment from another star system passing through on a hyperbolic path briefly lit by our sun, before vanishing back into the void. This interpretation allowed all to remain calm. It fit neatly into existing frameworks and required no fundamental revisions. However, as the object advanced deeper into the inner solar system, data began to accumulate in ways that defied simplification. There wasn't just one anomaly, nor two. A series of behaviors emerged that, when considered individually, could be brushed aside, but taken together, these behaviors formed a complex picture that is difficult to dismiss. This situation extends beyond a singular strange graph or an unusual image. It's about convergence. Before we delve into more detail, I want to clarify something. Nothing you are about to hear relies on belief, speculation, or sensationalism. What's changed in the last 24 hours is not the imagination of observers, but the increasing density of correlations. Independent measurements are starting to resonate with each other, and tomorrow, December 19th, is the day when those echoes will either dissolve into noise or crystallize into a discernible signal. If you're following this closely, you're aware that a major point of confusion regarding 3 Atlas has been its tail geometry, particularly the existence of what is termed an anti-tail. In classical cometary physics, an anti-tail typically isn't considered a physical structure at all. It's regarded as a projection effect, an optical illusion created when Earth crosses the orbital plane of the dust sheet. The particles themselves behave normally. It simply appears odd from our perspective. That explanation has sufficed for decades. However, the situation changed with 3 Atlas, as the anti-tail did not remain fixed. It did not merely appear and then fade as geometry shifted. According to new analyses circulating through preprint channels, it was observed to exhibit lateral motion leading up to perihelion, not dispersing or smearing, but oscillating. The scale of this structure is hard to overstate. Measurements indicate a length exceeding 400,000 km, which is beyond the distance between the Earth and the Moon. A coherent feature of that magnitude attached to an object generally estimated to be only a few hundred meters across. At such a ratio, intuition falters. Yet scale alone isn't the core issue. Astrophysics often handles extreme ratios. The real problem lies in the behavior. Loose particulate matter shouldn't oscillate coherently at that scale. Dust clouds are sluggish, plasma disperses, and solar radiation pressure smooths out sharp features. Still, the reported motion displayed neither chaos nor delay. It followed a specific pattern, a repeatable deviation noted just before the object reached its closest point to the Sun. That timing is critical. Perihelion marks the most extreme environment for an object like this. Thermal stress peaks, outgassing escalates, and radiation pressure strengthens. If a structure endures or worse becomes more organized under such conditions, it demands scrutiny. The oscillation also doesn't align with simple rotation expectations. If the nucleus were spinning and ejecting material isometrically, we would expect the tail's behavior to correlate with the spin period, but this is not the case. The motion appears entirely decoupled from rotation. This leads us to consider momentum. When you observe a large-scale feature changing direction or oscillating, it's vital to inquire about the forces acting upon it. Alone, solar wind cannot explain such controlled lateral motion without resulting in turbulence. Radiation pressure cannot account for rhythmic deviation. Something else must be at play. This is why Avi's commentary continues to emerge in discussions, not because he claims absolute certainty, but because he follows the physics through to its logical conclusion, even when that conclusion may be uncomfortable. A structured oscillation involving a sizable trailing feature signifies force application. Force application indicates control, whether passive or active. Moreover, the composition of the object is significant. The spectroscopic data linked to the anti-tail does not clearly resolve into the expected signatures of a typical comet. This does not automatically imply artificiality. Interstellar material can be chemically intriguing, holding compounds rarely observed in our own system. But again, context is crucial. When unusual chemistry coincides with unusual mechanics, the probability narrows. Consider the larger pattern. Over the past few weeks, 3E Atlas has exhibited repeated brightness irregularities, not random flares or smooth fading, but discrete dimming events that don't align neatly with distance, phase angle, or expected outgassing cycles. During its passage near Mars, the object appeared dimmer than predicted by models. As it advanced further inward, it dimmed again at points when we would expect brightness to rise. That alone is puzzling, but when combined with tail geometry anomalies, it becomes increasingly difficult to overlook. Brightness isn't an abstract metric. It is the fundamental observable property of an astronomical body, reflecting how light interacts with its surface and surrounding material. When brightness behaves in counterintuitive ways, it suggests that light is being absorbed or redirected in ways we don't fully comprehend. This is where light curve analysis becomes essential. A light curve is merely brightness plotted over time. For natural objects, light curves are often messy. Rotation introduces periodic changes, but they're noisy. Surface irregularities contribute scatter, and outgassing brings spikes and dips. Even highly regular rotating asteroids rarely produce perfectly clean curves. Recent segments of light curves linked to 3I Atlas show extended intervals of flatness interrupted by sudden drops, followed by recoveries, creating a repeated pattern. These are not flares. These are absences, dimming events with relatively consistent depth and spacing. If validated, this pattern indicates periodic occlusion or absorption instead of emission. Something is intermittently cutting down on the amount of reflected light reaching observers. Moreover, what's particularly troubling is the emerging temporal correlation between these dimming events and the reported oscillation of the anti-tail. Independent data collected by different observers seem to synchronize in timing. When one phenomenon shifts, the other reacts. This raises the possibility that what we're witnessing are not isolated anomalies, but rather different manifestations of a single underlying system. If the anti-tail is coherent and resistant to solar wind dispersion, we must consider electromagnetic effects. Plasma, confined by magnetic fields, behaves dramatically differently from dust. It can maintain its shape, transmit force, and interact dynamically within charged environments. Magnetic confinement at that scale would necessitate an energy source, though not necessarily an engine in the science fiction sense, at a minimum, an organized system able to sustain field structure. This does not equate to confirming technology. Nature can create magnetic structures, but it rarely produces them in isolation from other expected behaviors. Context matters again. Tomorrow's closest approach offers the optimal opportunity to test these interpretations. The geometry improves, phase angle stabilizes, and signal-to-noise increases. If the anomalies are artifacts of perspective or limited data, they should erode under better conditions. If they don't, the implications expand. Closest approach isn't only about distance, it pertains to alignment. It's the moment when relative motion slows angularly, leading to peak tracking precision when otherwise ambiguous structures become more distinct. Another noteworthy element has received less attention. Astrometric measurements indicate the anti-tail is not perfectly aligned with the solar wind vector. The deviation is modest in absolute terms, but significant within orbital mechanics, suggesting directionality not governed by solar forces. When analysts extend the vector defined by this structure outward, it points toward the galactic center, toward Sagittarius A, toward the location from which 3E Atlas originated. This alignment might be coincidental. The galaxy is vast, and numerous vectors point toward fascinating places. But the notion of coincidence becomes less comfortable when combined with coherence, timing, and modulation. Some have proposed that the oscillation itself could serve as modulation, not necessarily in a narrow communication sense, but as a method of encoding information onto a carrier structure interacting with the solar environment. While still speculative, this idea exists because the data suggests it. There's also the crucial matter of reflectivity. Observations indicate that 3E Atlas displays a remarkably low albedo, absorbing a large fraction of incident light. Fresh material from comets is usually reflective, particularly during active outgassing. While dark surfaces exist, when coupled with dimming behavior, low reflectivity raises significant questions. Why would an interstellar object become more difficult to detect as it approaches optimal illumination? Perhaps it's a matter of geometry, composition, or function. Absorbing light can be advantageous if one seeks to reduce detectability. It can also facilitate energy harvesting. This brings us back to timing. December 19th is not a random date. It marks a point where Earth, the Sun, and 3A Atlas find themselves in a specific alignment. During this period, certain types of interference diminish, and certain observational constraints ease. If something were to be measured, transmitted, or adjusted, this would be a strategic moment to achieve that. This doesn't mean that something must happen. It signals that if something were designed to happen, this would be the opportune time. Quietly in the background, there are reports of timing correlations within observational infrastructures. While nothing alarming or dramatic is officially noted, there's a subtle clustering of anomalies, slight deviations, irregularities emerging around similar timeframes across various systems. This isn't evidence of intent, but an indication of activity. Inactive systems do not produce synchronized irregularities. Tomorrow, the window will close, the geometry will shift, the object will retreat, and the opportunity will fade. If 3 Atlas is a natural phenomenon, we should gain clarity tomorrow. The tail should behave predictably, the light curve should become noisier, and anomalies should blur. Conversely, if it is not a natural phenomenon, we will witness the sharp emergence of contradictions. Therefore, here we stand, less than 24 hours away, observing an object from beyond our solar system that does not behave entirely like the classification it was given. It shows coherence where dispersion is anticipated, modulation where randomness usually prevails, and timing correlations clustering around stress and alignment moments. This does not equate to knowing precisely what it is. Rather, it highlights that we do not yet understand what it is not. That distinction is crucial. As we approach December 19th, resist the urge to settle on a narrative. Certainty too soon is the quickest way to overlook what is truly unfolding. Pay attention to the data. Monitor how it evolves under scrutiny. Observe whether independent signals converge or collapse, because in the next 24 hours, 3 Atlas will either resolve into a familiar category or compel us to establish a new one. Remain engaged with the data and stay vigilant.